This is the demonstration that goes along with Station 4 of Unit 12, and this is all about electrolytes. I have here a battery that is hooked up to wires that is hooked up to a buzzer. And if you connect the wires of the buzzer and the battery, the buzzer sounds. So anything that can conduct electricity from this wire to this wire will make the buzzer go off. So I have here a petri dish and some distilled water. If I pour distilled water in the petri dish, enough just to cover the bottom of the tray, it doesn't need to be very full, and I stick the wires into the petri dish, nothing happens, meaning that water does not conduct electricity. I also have here some potassium permanganate. If I stick the wires in the potassium permanganate, nothing happens, meaning potassium permanganate is not conducting electricity. However, if I dissolve the potassium permanganate in the water to make an aqueous solution, like this, then the wires, again in the water, don't make any noise, but if I move it into the area that contains the potassium permanganate, you can hear the buzzing. And if I move it into a higher concentration, the buzzing gets even louder. So this says that potassium permanganate will conduct electricity when dissolved in water. And that is the definition of an electrolyte. So an electrolyte is a compound that conducts electricity when dissolved in water. The opposite of electrolyte would be a non-electrolyte, which does not conduct electricity. Even if it's dissolved in water. So an electrolyte, when it's a solid, doesn't conduct electricity, but does conduct electricity when it's aqueous. A non-electrolyte will not conduct electricity under any circumstances. So there are two types of compounds, ionic and covalent. Knowing what you know about the fact that potassium permanganate conducts electricity, figure out whether ionic compounds are electrolytes or covalent compounds are electrolytes, and then continue on with the rest of the worksheet.